It's my pleasure to welcome our next speaker in this session, my colleague Andrei Sabelfeld from Department of Computer Science and Engineering here at Chalmers. So Andrei is known for his work on specifically web security and software security in general. Also been working on issues relating to location privacy. Today's talk will be focused more on the web and the web of things. I think one bit of evidence that Andrei must know something about this topic is that he's one of the very few researchers, he's identifiable in Sweden as perhaps the only researcher who's receiving direct research funding from both Google and Facebook. So that must in itself say something. With that, I'd like you to welcome Andrei. Thank you.
Okay, thank you. So this talk is not going to be about Facebook and Google this time, but about Web of Things. So this is the topic today. What is Web of Things? I'd like to start with that. And of course, the main driving force and the motivation here is the Internet of Things. Okay, so the Internet of Things drives a lot of innovation and connects very different types of systems that were not previously connected. Right, so you see examples of medical systems talking to smart homes, smart grids, all of these systems becoming more and more connected. So that's great. It creates a lot of innovation, a lot of interesting new features. But unfortunately, it comes with a big share of problems. Okay, so one of the main problems with IoT is that it's fragmented. Okay, so essentially, there are a lot of platforms around, a lot of standards that are really hard to make to work together, right? So that's a really kind of big challenge with IoT. To help address this challenge, so there's this effort called indeed the Web of Things, and have here a quote of CEO of W3C. It's a standardization body that standardizes web platforms. And essentially, the hope there is that the web has been solving a similar problem to IoT in a sense that there are a bunch of unconnected platforms and components. So how do you get to talk? How do you get them to talk to each other? Right. So different browsers, different server frameworks, different databases. So in the web, this has been very much the focus of trying to get them to work together. And W3C has been kind of driving some of these standards. So that's good. So how about we leverage what the web has done and try to apply it to IoT? So sounds good on surface. But then, so the center of today's talk is security implications. The web is not known to be particularly secure. We see attacks every day in the news. So the challenge here is how to make sure that we bring the best from the web, but we make sure that we don't inherit the insecurities that the web is famous for into the IoT domain. Okay, so that's really a big challenge for us. So more about this. So if you move from the web to the Web of Things, so we see that it's really the JavaScript that is at the heart of driving new features on the web. Okay, and this is also what we see more and more in the Web of Things, as I'll discuss. What makes it really easy with JavaScript is that, there are all possibilities for integrating third-party code. So this is one of the very nice things with JavaScript. If you know about client-side web programming, it's extremely easy to include somebody else's code from third-party, load it from a different server to work in the context of your application. So this is the beauty of this. It's extremely easy integration. Right, that's what you get. It's a very powerful feature, essentially, and it's used a lot. So just here I'm mentioning that typical website, you go to a news portal, it would actually, most of the content would be remote content if you go there. It's all kinds of scripts and libraries that'll be part of the web page, and the actual news would be a very small percentage of the content that you actually will see. So it's extremely powerful, and what is it good for? Well, you get libraries, for implementing functionalities from the scripts, various gadgets. We talked about Facebook. You have like buttons from Facebook everywhere. It's based on this kind of gadget mechanism. And then advertisement. So that's another very common types of scripts that you would include from other sites. Another types is analytics. So essentially, you want to. Claudia was talking about tracking. Okay, and there's this fine, kind of line between legitimate analytics when you want to check what features your users are using on the website. Heat map of a page, how many times people click on the button. Versus somebody who actually tries to really record everything that users do, and as Claudia was mentioning, doing fingerprinting, right, and kind of more kind of malicious type of tracking. And just to give you an example here, yeah, this is a fine line. It's actually, one line of code written in a mistaken way can actually, fool you from one side to the other. And recent news on that was analytics scripts from Mixpanel, which essentially accidentally collected, together with the data about usage of websites, also the passwords of users, and stored it on, or sent it over to the analytics websites. So clearly, it's not an intended way of using analytics scripts. So as I mentioned, so JavaScript inclusion mechanism is very powerful, but you see some examples where so the power is uncontrolled. It's unleashed, and passwords are collected, and before you know it, everybody has them on the internet. So that's a concern, and indeed, so much of the JavaScript-based attacks, so they exploit this easy integration feature in web applications. And just to mention a few, so exfiltrating information, so it's really easy to accomplish with JavaScript, as in the example of passwords. Malvertising, when the way you provide space on a website is used by an ad script, which can potentially infect the machine, right? So it can go really a long way there. Defacing websites and phishing attacks. So again, using a JavaScript that you load from a third party, you have full privileges on the web page. Therefore, you can render the web page in any way you like, so that it looks like a bank, and suddenly it asks you for your login credentials to a bank. There was a recent case with Reuters website that was defaced, not by attacking the website itself, but by attacking a gadget that Reuters site was using. So that's sufficient because the privileges that scripts get, that the ones that are loaded on a web page, are the same as of the web page itself. Okay. So essentially, by including these 70 different scripts from 70 different sources, you also extend the attack surface to 70 new possibilities. So it's enough to attack any of the 70 sources in order to be able to attack those that use your services. So it's a concern for us, and well, if we want to use JavaScript and integration powers of languages like JavaScript for IoT, well, that's something that we really want to worry about. So I'd like to give two examples where these types of problems show up directly. So we want to use JavaScript for Web of Things. And I'd like to discuss what we do at Chalmers to address those problems. The first example is an up-and-coming service called IFFT, which stands for If This Then That. So it's an extremely popular service, and essentially what it is a web-based platform for IoT, allowing users to connect the different type of services they use. So Claudia mentioned Fitbit, for example. So here, the service from Fitbit can be connected to IFFT, whereas social networks, smart homes, essentially everything that can possibly be connected to the internet. These days, it has many of these services, they have presence in IFFT. So you can use the web-based platform in order to connect these different services in a new way. Okay. So yeah, so there are already millions of users and billions of running applets. What is an applet? Well, applet is actually the central concept for IFFT. It defines what IFFT service actually does for a given user. And the way it works is actually very simple. So it's a very simple snippet of code, if you like. And the example I'm using here is existing applet from BMW that enables you so that when you park your car, you want to know where exactly you parked it. So the functionality here is that you get an email with a map where the car is parked. Okay, so you see, so there's the car part and the email part. They don't talk to each other normally, but thanks to this IFFT service, actually it's possible to connect them, right? So this is the new thing with this platform. So what happens here is that, well, so the way the applets work, if this, then that. So a very simple reactive model. So if you park a car, then you get an email with a map, right? And what does the actual functionality? It's a snippet of JavaScript. So it's gluing the two different services in the cloud, right? So it's the JavaScript execution takes place on IFFT servers. Okay, essentially, so you already see the danger here is that for this to work, you actually need to give out your secrets to IFFT, right? And similar platforms. What also makes it popular is the end-user programming model, right? So I'll talk more about this. So the idea is that for rich features, basically you open up for everybody to submit applets, and any user can publish their applets so that other people can use. So that way you have a very rich kind of app store model that really drives the progress with IFFT. Okay, but so we see that applets have access to sensitive information, in this case location. So what can go wrong, right? Especially that we have JavaScript being the glue between location and email services. Well, so if you have a malicious applet maker, right? And so remember, everybody can be an applet maker, and if there's no restriction, then of course you use the powers of JavaScript to send location somewhere else, not necessarily in the email to the user, right? So you essentially exfiltrate the location, and there are ways of doing it from on the platform through the JavaScript and send the location elsewhere. So that's not good. And in fact, if you look closer, so what happens is that there are many other sensitive sources that an applet can access to, right? So location is only one, but as I mentioned, so many other services are connected to IFFT. So basically, users give access to email, to their Facebook feeds, to local files, to the voice commands of a Google Assistant. So they're all services that actually enable IFFT to get access to this, right? To program various fun things. But of course, once you do that, okay, there's this, you immediately create the possibility for malicious applet makers to exfiltrate this. So much for user privacy, but that's we don't stop there, because the other things applets can do, they can affect integrity and availability, right? So of users, in terms of so sending emails around, there's a capability for that. Writing on Google Drive of a user and deleting data from users' accounts, and even affecting things related to smart homes. So switch off the thermostat, or various other things you can do with the home. So that's essentially, you have third-party code, being uploaded, right? Okay, how do we make sure that this doesn't happen, right? The privacy violations, integrity, and availability. So very interesting problem. Second example I'd like to bring up, so where we have very similar problems, but in a slightly different context, is the in-car app stores. So the idea is exactly the same there. So car manufacturers move to open up their infotainment stores to third parties, which enables innovation, enables all great features, right? So we've seen this, interesting examples from the smartphone domain, where you have enormous app stores with a lot of different interesting apps. So similar idea is here, and different manufacturers do it in different ways. So General Motors opened up for JavaScript and HTML5 to be the main language for infotainment app stores. In the case of Volvo, they recently announced that they'll follow Android model, and in 2 years' time, in all new Volvo cars, you'll have Android-like app store as well. Okay. So these stores are, so third-party stores. So anybody can well, not anybody, but at least third parties are the ones producing the code for those apps that you would run. But then if you look And what happens is that in the case of General Motors, so it's 400 data points, as you see here in this article that they mention, that actually are available to to one of those apps in the car. What are these apps? What can they get access to? Well, location. So Claudio just mentioned that location is extremely sensitive. You need 4 points, and then you know everything about the user. So of course, location of a car is a major giveaway if you are able to track that. So well, that's what you typically. So you would have a possibility for infotainment apps to get access to it, as well as other types of information, including camera and microphone. So to be fair, some of these accesses, they require permissions, which you might also recognize from smartphone app stores, but some don't. So for some of these sources, actually you can get implicitly or explicitly this sensitive information without permission. Okay, what can these apps do? Well, so they're connected, so they can exfiltrate information, right? So location can be tracked and exfiltrated if there is no protection in place. But also they can perform disruption attacks, so that as a car reaches higher speed, so we have access to speed, which we can see from the applet, from the app here. Okay, you might shock a driver by maybe cranking up music volume or changing the seats configurations, right? So you see all possibilities for potentially increasing risk of accidents. So that's why we want to focus on this and address security for these scenarios, right? So essentially rich IoT-based settings with third-party code involved. Okay, so what can we do about this? How do we secure this, right? And that's where research at Chalmers comes into place. The key observation here is that what really controls the IoT settings here, both in IFFT and with the cars, so it's the code, right? It's the code where the vulnerabilities are and where the attacks are. Therefore, we need to focus on the code and secure the code in order to prevent those attacks. And the way we do it is essentially by following one of the main principles in computer security, principle of least privilege, right? We try to give only as much privileges to those apps that are actually required to perform the tasks that are intended, right? So this is like the main principle. And so there are different instances of how we actually can enforce this principle. And one that I mentioned here is API control, or loosely permissions and privileges, right? So that essentially, you constrain what an app can do in different ways. So for example, for location, Claudia mentioned generalization. That's a very nice way to do it. Maybe if you have an app for points of interest around your area where you're driving, then you don't need to give away the exact location. It's enough to give a region of a city, and then pull all the data about points of interest around you without leaking where exactly you are. Maybe for volume control, for microphone access, if you install an app in the car, actually you don't need to always allow access to a microphone. Maybe it's wise to force the app to subscribe to certain voice commands that it would actually need to react to, and that way only the system will have the access to the microphone, and the app only will get commands once they're issued by the driver. So that can go a long way, but in some cases, just permissions and access control is not enough. So as we've seen with the example of parking the car, actually we do need full location, and we do need to send the email. So in those cases, we apply technology of information flow control, where we track information from sensitive sources to public destinations, and we make sure that it's not exfiltrated that way. And there, an example from Chalmers research is a tool called JSFlow, which performs this kind of tracking for JavaScript. So you can view it as a dynamic monitor that looks at JavaScript execution and tracks the label of information. And if you try to send a location on the internet, it would prevent you from doing so. So wrapping up, so a challenge with IoT is fragmentation. Web of Things can be helpful there by new standards and platforms that take lessons from web security and apply it for IoT. But the key here is really to focus on application level security policies and enforcement mechanisms, where permissions, privileges, and information flow control can help a long way. Thank you very much.
Thank you, Andrei. Question at the back. So the question is, what can you do about the humans? You can't control the humans quite so easily as you can the technology, and how do you stop them from doing the wrong thing?
Yes. So, so essentially, we should try as much as possible from the technical perspective to make it easier for humans. And so one interesting example, since web tracking was discussed before by Claudia in the previous talk, is these pop-ups that we have now everywhere on websites. So I think it's a non-example how we should not annoy humans about privacy. So privacy does not mean that you should click OK, on every website, so that because it wants to use cookies. So in this case, rather, I would go for a solution that Apple has been pushing by trying to identify which cookies are actually needed for functionality because you happen to visit the websites, and which cookies you can actually wipe out because they're clearly third-party cookies. So I think that's a good example where we can try to make it more convenient for humans and not to involve them.
Okay. Thank you again, Andrei.